This lesson we're going to be adding and subtracting mixed numbers. Now remember, a mixed number is a fraction with a whole number in the front. So if I have a whole number with a proper fraction, then I have a mixed number. So when I'm adding mixed numbers together, the main thing here is the fraction, right? We're looking at fractions here. Whole numbers, 3 and 1, we can just add them together. So for the wholes, we have 4 wholes, and then we have the fractions that we have to worry about. So in this case, I'm going to just add the whole numbers, and I'm going to add the fractions. So 3 plus 1, the whole numbers, that's going to become my new whole number. And then 3/5 plus 1/5. Now again, from the last few lessons in adding fractions, we have to make sure that they have a common denominator, right? So in this case, this fraction and this fraction both have a denominator of 5, so we can go ahead and add those fractions. It's going to be 3 plus 1. I'm adding the numerators. 3 plus 1 is 4. And then my denominator stays the same, as always, as a 5. So this mixed number plus this mixed number equals this mixed number. Okay, and then when you have your answer, when you find the answer, you have to make sure that this fraction here is a proper fraction, meaning the top number must be smaller than the bottom number. So if that's the case, then that's your answer, 4 and 4/5. Okay? So let's do a few problems. We are adding 2 and 1/2 plus 2 and 2/3. So again, I'm going to add the whole numbers together. So this whole number and this whole number, that's going to become 4. And then I'm going to add my fractions together, 1/2 plus 2/3. But there's a problem. Our denominators are different. So whenever you have fractions with different denominators, then you can't add them or subtract them until you make the denominators the same. So in order to make the denominators the same, you have to look for the least common denominator, or the least common multiple. So between 2 and 3, the least common denominator will be 6. Okay, so it's 2. The multiples of 2 would be 2, 4, 6, 8, so on. For 3, 3, 6, 9, and so on. So the least common multiple is 6. So then I have to change these fractions. Okay, I have to convert the fractions so that the denominators will become a 6. So 1/2 I'm going to multiply this 2 by 3 to get a 6, right? So 2 times 3 is 6. So whatever I do to this part, I have to do to the top. So 1 times 3 is 3. Again, you have to multiply the top and the bottom by the same number. If you don't, then you're actually, it's going to be wrong, because these fractions have to stay the same. Okay, all you're doing is changing the numbers, but it's still the same fraction. Okay, and then we have to do this next one, 2/3. So 2/3, again, I have to change it so the denominator will become a 6. So 3 times 2 became 6. So I have to multiply the top number by the same number. It's going to be 4. So this mixed number could be the same thing as 2 and 3/6. And this one can change to 2 and 4/6. Okay. They might look different, but they're the same thing. This problem is the same problem as this one. as long as you did everything correctly, okay, all you did was just change the denominators or change the fractions so that their denominators will be the same. So, again, I'm going to add the whole numbers. So it's 2 plus 2, which is 4. And then, since their denominators are the same for the fractions, I can add them. So it's going to be 3 plus 4, which is 7, over, the denominator always stays the same, so it's going to be 6. Now let's look at this answer right here. I have a problem. Because I have 4 and 7 over 6, remember my mixed number? This is supposed to be a mixed number. The mixed number has to be a whole number with a proper fraction. But since my numerator is bigger than my denominator, this is actually an improper fraction. So I have to change this so that this will no longer be an improper fraction. So let's just look at just this part right here, 7 over 6. 7 over 6, since it is an improper fraction, we can change this so that it becomes a mixed number. So remember, I asked myself, how many times can 6 fit into the top number 7? I know that 6 can only fit into 7 one time. Okay, so if 6 fits into 7 one time, how many do I have left over? I only have 1 because I have 7, so 7 minus 6 would be 1, and then again my denominator stays the same. So this right here, 7 over 6, became 1 and 1/6. But then again, I have a 4 right here. I have another whole number 4, right? So I have a whole number 4, and I have a whole number of 1. So since this 4 is the same thing as, or this 4 and 7 over 6 is the same thing as 4 plus 7 over 6, I can just take this whole number and add them together. So this will become 5 and 1/6. So again, if your answer, your mixed number, has an improper fraction, you have to take out the whole number, okay? Change your improper fraction into a mixed number, and then add your whole number to it. Okay, so then 7 over 6 became 1 and 1/6. I have a whole number 4 that I have to consider, so I'm going to add that 4 to that mixed number. So it's going to be 5 and 1/6. Okay, and that is my answer. Okay. So another example here, I have 6 and 5 over 7 minus 2 and 1/5. So the main problem here is my fraction, right? I have to look at my fractions, 5 over 7 and 1 over 5. My denominators are different, so I have to make sure to make a common denominator. So now normally you can do the factor tree to find the least common denominator, but for 7 and for 5, they're both prime numbers. So if they are both prime numbers, then you can just list out all the multiples, or the first few, until you find the common multiple. So 7, 14, 21, 28, 35. For 5, the multiples are 5, 10, 15, 20, 25, and continue right here, 30, 35. Okay, I found one, 35. And you have to make sure when you find the least common denominator that it's the smallest one. They're going to have more than one common denominator or common multiple. You just have to make sure it's the least common multiple. Okay, it's the smallest common multiple. So in this case, it's 35. So I'm going to change just this fraction. Now I'm going to ignore my whole number for now, okay? So I'm just going to change the fractions. So 5 over 7. Okay, I want to make the denominator become 35. So 7, what did I multiply by 7 to get 35? Multiplied 5, right? So then I have to multiply this top number by 5. This becomes 25. And then I'm going to look at this fraction right here. So 1/5. So 5 times 7 became 35. Multiply this top number by 7. Get 7. Okay, I'm going to rewrite my mixed numbers, my problem, so that I'll have common denominators for each of these. So this becomes 6 and 25 over 35 minus 2 and 7 over 35. Okay? So then, now that I have common denominators, I can go ahead and subtract these two fractions. So let's do 6 minus 2, the whole number, 6 minus 2, which is 4. And then I can take my numerator here, subtract it by this numerator. 25 minus 7 is 18. And then my denominator stays the same as 35. Okay. So my answer here is 4 and 18 over 35. And again, you have to look at this fraction right here, this mixed number. Make sure that this is a proper fraction. Your top number, your numerator, is going to be smaller than the denominator. Okay, this next example, 3 and 3/4 plus 4 and 1 over 10. Okay, again, I have to look at my fractions because I can't add them until I have a common denominator. So in this case, you can either, just like the other examples, to find the LCD, you can list out their multiples. Since these are not prime numbers, you can do factor trees. So I'm just going to do the factor tree. This is 2 and 2. Okay. And then for 10, it's going to be 5 and 2. There's a common number of 2. Okay, cross one out. Then my LCD, my least common denominator. I'm going to write out all the remaining circled numbers. Okay, 2 times 2 is 4, times 5 is 20. So my LCD is 20. I'm going to change these two fractions so that my denominators will become 20. So 3 over 4. Okay, 4, I multiplied it by 5 to get a 20. So I'm going to do the same thing to the top. 15. And then the other fraction, 1 over 10. So 10 times 2 became 20. 1 times 2 is 2. Okay, so again, this fraction 3 over 4 is the same thing as 15 over 20. And 1 over 10 is 2 over 20. So I'm going to rewrite this problem. 3 and 15 over 20 plus 4 and 2 over 20. Okay. I add my whole numbers together. It's going to be 7. Then I have to add my fractions. They have a common denominator, so I can add them together. I'm going to take my numerators, 15 and 2, add them up, and I get 17 over, and guess what my denominator is going to be? 20, okay? Your denominator has to stay the same. Now, I look at this answer. Is my top number in my fraction smaller than my bottom number? If it is, then it's a proper fraction. So this is going to be my answer, 7 and 17 over 20. Okay, this next example, 12 and 9 over 11 minus 12 and 3 over 22. Okay, before I begin here, I have to make sure that the denominators for these fractions are the same. Okay, so then I'm looking at this fraction here and this fraction here, right? So here I have an 11 as my denominator, and this one I have a 22. So I have to make sure, I have to change these denominators so that they're the same in order for me to be able to subtract these fractions. So I need to find the least common denominator. Okay, so I'm going to write out the multiples of 11, 22, 33, and so on. And then for 22, it's going to be 22, 44, and so on. Okay, so then my least common multiple is 22. And since they're denominators, it becomes the least common denominator. Now make sure, if you're going to list out the multiples to find the LCD, then you have to find the one that's smallest. Okay, it has to be the smallest common multiple, because these two numbers are going to have more than one common multiple. So it has to be the smallest one. So now that I have my LCD, I have to make sure that these fractions will be converted so that I'll have my denominator as 22. So this fraction right here, 9 over 11, now I know I have whole numbers here, but I'm just going to worry about my proper fractions first. So 9 over 11, I want to make that denominator 22. So I take this number 22 divided by 11, or I can just figure out 11 times 2 gave me 22. So whatever I do to that number, I have to do to the top number. So to multiply the top number by 2 as well, 9 times 2 is 18. Now this next fraction, 3 over 22, the denominator is already 22, so we don't have to change it. We can just keep it the way it is. So I know that 9 over 11 is the same thing, it's the same fraction as 18 over 22. So then I can just rewrite this whole problem so that they'll have common denominators. 18, let me erase that. 12 and 18, it has to change this to this fraction right here. 12 and 18 over 22 minus 12 and 3 over 22. Okay. So again, double check your denominators, make sure that they're the same. Okay. And then we can go ahead and subtract those. So for this, my whole numbers, 12 minus 12, is going to become 0, right? So then I don't have to worry about my whole numbers for now. I have to subtract my numerator, so 18 minus 3 is 15. And then my denominator, again, it's the same as 22. My denominator for my answer has to also stay the same. So it's 15 over 22. I don't have a whole number because 12 minus 12 gave me 0. So then I don't have a whole number here. Okay. So here I have to make sure when I have my fraction that this top number is smaller than the bottom number. So this is a proper fraction. And I can't simplify it because they have 15 and 22 do not have any common factors. There's no number that can go into both the top number and the bottom number. So once I ask myself all those questions and I can't simplify, then this would be my answer. So 12 and 9 over 11 minus 12 and 3 over 22 became 15 over 22. Okay, so that's it for this lesson. Thank you for watching educator.com.